Hello, welcome to ResoCoder. There are many simple mobile games out there that are extremely popular, and Knife Hit from Estoty, which is published by Ketchapp, is no exception. How simpler can a game really be? It doesn't matter how simple the game mechanic behind the game is, but the only thing that really matters is if the game is actually fun to play. That's what separates successful games from those on the mobile game graveyard. In this tutorial series, which is comprised out of 2 parts, you are going to learn how to create a replica of Knife Hit. In this first part, you are going to learn specifically how to create this awesome rotating lock, and also how to shoot a single knife and make it stick to the lock like this. The spawning of the knives and this nice UI will come later. We will also add game over effects and particles which are not yet implemented in this preparation for this tutorial, so you have something to look forward to. If you don't want to miss those future videos, that one video actually, and many more which will be coming on this channel, subscribe to this channel and also hit the bell button so that you are not going to miss those. As you can see, this tutorial uses custom sprites, which you are free to use if you would like to follow along with the same exact sprites. It's also completely fine to create your own artwork. It's actually rather encouraged. I use an open source vector graphic software called Inkscape if you are interested, so go ahead, download them from the link in the video description, which is gonna take you to resocoder.com, or create your own sprites. So let's create a new Unity project, name it something like Knife Hit, and make sure that you have this 2D template selected. Now let's hit Create Project. With the new project created, let me also tell you that you can follow this tutorial in a written form, so that if you have some questions after watching this tutorial, if you want to learn it on your own pace, you can check out the link in the video description. There is the post, the written blog post, and it's going to take you to resocoder.com. That's also where the sprites for this tutorial are located. First up, we want to create a new folder under Assets, so right-click, Create Folder, and we are going to name it Art. And we want to drag all of the sprites, which are downloadable from resocoder.com, over to this Art folder. So I have them here, and we are going to select these 3 sprites. You are going to have this zip file and drag them over to the Art folder. Now select all of them in the inspector, so Shift and click on the last one, and we are going to change their pixels per unit over here to be 300, so they will be a bit smaller when we drag them over to the scene. And be sure to hit Apply so that these pixels per unit are actually applied. Next, make sure that you have the correct aspect ratio of the camera right over here. I already have 9:16. You will probably need to create a new aspect ratio because we are creating a mobile game and normally you have 16:9, not 9:16, right? So you simply click on this plus, you say aspect ratio instead of fixed resolution, and you put here 9:16 and hit OK. Or another option is that we are currently building for, when we go over to build settings here, we are currently building for PC, Mac, and Linux standalone. You can also build this for Android or iOS and hit on switch platform if you want to switch platform to that particular one. We are not going to do that in this tutorial, but the awesome thing about Unity is that once we have this project created, you can really simply export it to Android. You will not have to do anything else, anything special. You can even export it to iOS. All you do is that you switch the platform and it's going to automatically do the work for us. We won't have to change any code. However, because this tutorial doesn't deal with deploying it on the Play Store or on the App Store, right? We are going to be building for PC or Mac or Linux. So we are not going to switch platforms. When you have a switched platform, you will have the platform resolutions here, so you won't have to do all of this new resolution adding. And as the last thing in changing the look and feel, we are going to change the background of the camera to a nice dark shade of blue. Now this one, actually, it's going to be pretty cool. This is the shade of blue which the Knife Hit game from Ketchapp uses. or at least it's really close to that, and the code is 021C32. You can also add a custom background as a child of this main camera if you want to draw something nice, but for the sake of simplicity we are going to use just a background color. Now let's get into creating the actual game, right? We are going to first create an empty game object, so right click, create empty, and we are going to call it log motor. So log motor, and we are going to center its position, but it's already centered, so we don't have to do that in this instance, but sometimes you might have some weird coordinates over here, so just set it all to 0 except for the scale, obviously. We are going to add a new component on this game object. Its name is wheel join 2D. So this automatically adds also a rigid body for us. We want to set this rigid body's body type to be kinematic so that the outside physics forces are not applied to this log motor's rigid body. We will use this wheel join to actually move the log to be rotating. Next up, drag this log sprite from the art folder over to the log motor here. This is going to create a new child game object of the log motor named log. We're going to change its name to be log with a capital L, so log with capital. And it should not be centered, so we are actually going to move the log motor, the parent, to a y coordinate position 2. So it's a bit up. On this log game object, which is the child of log motor, we want to add two new components. One of them is rigid body 2D, so search for rigid body 2D, and then also circle collider 2D. We are going to change the values of rigid body 2D to be linear drag will stay at 0, but we also want to change the angular drag to be 0, and the gravity scale should also be 0 because we don't want the log to be falling down. It should be actually stationary, so we don't want the gravity applied on it. And we are going to also change the radius of the circle collider because, as you can see here over in the scene view, it's all the way to the edge, but we want to change it to be 0.75 so that it's actually inside. I don't know if you can see it properly on YouTube, but it's right over here. Right over here is the new log's radius edge. So this is because when we hit the log with a knife, we want it to actually be stuck inside the log. So it's the blade of the knife will be stuck this distance between the edge of the sprite and the edge of the collider, right? That's why we need to have this area where the collider is not present. The log motor's wheel join 2D will have a motor, actual motor applied on it, and it's going to move this log child object. It's going to rotate it, actually. What we need to do as the last step is to drag the log child game object of the log motor over to the connected rigid body right over here. We want to drag it inside here. So the log is a connected rigid body of the wheel join 2D, which is present on the log motor game object. Now that we have all of the prerequisites in place, we are going to dive into coding by scripting the log rotation. To make things organized, let's create a new folder under assets and call it scripts. I always like to do this. Scripts, all right. And inside this scripts folder, we are going to create a new C# script and we are going to call it log rotation. Let's open it up in Visual Studio and we are going to write this script bit by bit. First, let's delete this void start and void update, and we are going to create a private inner class called rotation element. So private class rotation element, and this class will contain two fields, public float speed and also public float duration. So what will this do? This custom class represents a single rotation element of the log's rotation parent. You know, the log will be once moving to the left side, or actually rotating to the left, or not to the left, it cannot be rotating to the left, counterclockwise or clockwise, let's put it that way, right? So it's going to be rotating counterclockwise or clockwise for 3 seconds, and then it's going to change to other direction for 5 seconds. This is the single element of that full rotation parent, right? So we also need to make this class to have an attribute, or attribute annotations are in Java. This is attribute in C#, right? It shows that I am doing also Android, right? So system.serializable is the attribute that we need to have in here, and this will allow us to edit this custom class in the Unity editor just like a simple field. If it wasn't there, we couldn't edit this class from the editor, right? We also probably want to put a preprocessor directive. You don't have to do this, but otherwise it's going to throw us some obnoxious warnings about these fields not being properly initialized in the Unity editor. And warnings, who likes warnings? Nobody likes warnings, so we are going to get rid of those warnings. So we are going to put a pragma warning and disable. We want to disable a warning, and the warning code is 0649. So we are good to go here. And a good practice, although we don't have to do this here, but a good practice is to enable the warning, so restore the warning after the fields in question are sorted. Next up, we are going to create a private field of rotation element array. So rotation element, and it's going to be an array, and its name will be rotation parent. Parent, if I could spell. And we also need to serialize field. This is a Unity's attribute from the Unity namespace, and it forces Unity to serialize a private field. It doesn't need to be public, so that's why we have it private, because we don't want to access it from our classes, but we need to be able to set it from the Unity editor, and that's why we are serializing it so that we can edit it from the Unity editor. And this is the aforementioned full rotation parent of the log, which is comprised of single rotation elements. Next up, we are going to create a private wheel join 2D. Its name will be simply wheel joint, as it's already suggested by IntelliSense, and then private joint motor 2D. Its name will be motor simply. So this wheel joint will be set to the wheel joint 2D from the log motor object. We are going to simply get the component which is already added to the log motor. And this motor is basically something has to be moving the log, and we are going to utilize a motor for that rotation movement. So we need to have it here. Next up, we are going to implement private void awake lifecycle method. And inside awake, we want to set these two fields. So we are going to set wheel joint to be from the component. So get component, which is already present on the log motor. And the component's name is wheel, or actually class is wheel joint 2D. So we are going to get it as this. And for the motor, we need to actually create a new instance of the motor. So motor is equal to new joint motor 2D, and that's it. Now we have this rotation pattern, and we need to be able to somehow put it into practice. We need to be able to play this rotation pattern. That's why we are going to create a new coroutine. So a coroutine in Unity is created as an IEnumerator returning function. So we are going to create private IEnumerator, and implement the namespace by hitting Alt and Enter. So we want to be using system.collections, and its name will be play rotation pattern. And before we do anything inside this coroutine, we are going to start this coroutine from the awake. So as soon as this script is initialized, as soon as it awakes, as it's called in Unity, we are going to start playing the rotation pattern. The simplest way to do this is by calling start coroutine and passing in the name as a string. So play rotation pattern, we can actually copy it and paste it inside here, and this is going to start the rotation pattern as soon as this awake function method, actually as it's called in C#, as this method starts. Alright, inside this play rotation pattern coroutine, we are going to first declare and initialize a rotation index to be 0 at first, and then we are going to create an infinite coroutine, so we need to have an infinite loop, so while and true to make it infinite. And when this loop will be running, we want to work with physics because we want to rotate the log, and that's why we are going to execute it. We are going to need to execute it as if we were running in a fixed update method. To execute an enumerator coroutine as a fixed update, there is one really handy yield return statement, and that is that we want to yield return, so basically wait, and we want to wait until we get a new fixed update, so wait for fixed update. This way, this coroutine and the fixed update will be synchronized. As soon as this coroutine is synchronized with the fixed update cycle, we are going to set the motor speed to be equal to rotation pattern, and we want to get the rotation element at rotation index, and we want to get the speed from this rotation element. Then we are going to set the motor's max motor torque to be equal to 10,000, and this is a hard-coded value, and feel free to experiment with other torques if you wish, but 10,000 works pretty cool, so I'm not going to change the default value here. Then we need to set this updated motor, because remember, this motor is this field right over here, which is highlighted, this field. So we want to set this updated motor to be sitting on and moving this wheel joint. So we need to get the wheel joint from the field, and we want to set its motor to be equal to our motor, which we have just updated with the speed and torque. And then we want to let the motor do its thing for the specified duration. So we are again going to wait in this coroutine. So again, this is done as yield return new, and this time we are going to wait for seconds, and I like always to wait for seconds real time, so that when we change the time scale of the game, we are not going to mess this up. We are not going to be changing time scale in this tutorial two-part series, but just in case you have some other game in which you are doing this, I always wait for seconds real time and not just for seconds which are affected by time scale. And we are going to wait for seconds from rotation pattern, and we are going to get the rotation index, and we want to get the duration from this rotation element just like this. And then we want to increment the rotation index, so rotation index plus plus, and because this is an infinite loop, we need to check if we need to set this rotation index back to 0 so that it can loop right from the start and again to the end of the rotation pattern, and always looping from the start to the end, and then always setting back to start and going to the end, right? So we need to do this in here. So after we have incremented the rotation index, we are going to set it again and set it like this. If rotation index is less than rotation pattern length. And if it's less than length of the rotation pattern, we are going to set the rotation index to be equal to rotation index. So we are going to not touch it. We are going to leave it as it is after this incrementation. However, if the rotation index is greater than the length, this means that we should be looping back. So we need to set it back to 0, just like this, colon and 0. And something is not cool here. What is it? Type of conditional expression cannot be determined. Wow. Rotation pattern, right? Not rotation pattern. We need to put here rotation index. My bad. Now it's working just fine. So rotation index over here and 0 on the right hand side of the column. Alright, now let's get to Unity Editor, and we are going to drag this log rotation script to the log motor game object, and we are going to set the values of the rotation pattern. The size will be 7, and feel free to set your own things inside these elements. So these are my values, and you can feel free to experiment with your own values. The best thing about this approach is that the rotation of the log is fully modular, and you can even generate it fully randomly at the runtime of the game. So if you want to have multiple levels, you can do so really easily. Alright, now that you have the rotating log, it's time to hit it with a knife. In this tutorial, you are going to make a simple knife, and in the next and final part, you will make them spawn a certain number of times and also create the accompanying user interface. To create a simple knife, we are going to drag the knife sprite over to the scene, just like this, and we are going to set its position of the knife to be 0, y will be minus 3.5, and the z will be also 0, and let's also change the name to be knife with a capital K. On this knife we want to add a rigid body component, so rigid body 2D, and we are going to set its gravity scale to be 0 from the start, because we don't want it to be falling down as soon as the game starts. And we also want to have a box collider 2D on this game object, and we are going to set its size to be x will be 0.5 and y will be 2. The box collider needs to be a bit wider, as you can see here, than the actual width of the knife sprite, because otherwise the knives could be appearing to be overlapping, which is not how the knife hit game works. Knives cannot be overlapping, but because of the funky Unity's collision detection, we need to make sure that the collider is a bit wider than the actual knife. Alright, cool, now let's get to scripts, and we are going to create a new C# script and call it knife script, and open it up in Visual Studio. Let's delete void start and void update for now, and over here first we want to have a private vector2 throw force field, and it's always going to be serialized field as before, because we need to be able to edit it from the Unity editor. That's why we always need to put this serialized field attribute on it, or above it actually. And then private bool is active, and it's going to be true by default. And knives shouldn't be controlled by the player when it's inactive, so when the knife already hit the log or hit another knife, we don't want to be able to move it or do any such things. That's why we have this is active on here. Then we are going to create private rigid body 2D RB, and this will be from the component which is already present on the knife game object. Rigid body is used for controlling the physics. And then the box collider 2D, so knife collider, it's going to be its name. And this is the box collider, which is also attached to the game object. Then inside private void awake, private awake, we are going to initialize these two fields, so RB is equal to get component rigid body 2D, and this knife collider is equal to get component, and this time it's going to be box collider 2D. All right. Then inside private void update, we are going to check if the mouse button, if the left mouse button is pressed. So if input, and this, by the way, works also for touch screen. So if you tap the screen, this mouse button will be registered as if it was down, even though you probably don't have a mouse attached to your phone, probably. So get mouse button down, and we want to get the 0th mouse button down. And also we want to check if the knife is active, because otherwise we don't want to affect it with any actions. And if it is active and we just pressed the mouse button or we touched the screen, we are going to add force to the rigid body. So rb.add force. The force for throwing the knife is simply throw force, which we are going to set in the Unity editor here. And the force mode 2D should be impulse. So 1 impulse for throwing the knife. Also, once the knife isn't stationary, but it's actually thrown, we can apply gravity to it so that it actually is affected by gravity, but only once it's actually going upwards, because otherwise it would simply fall down. But once we have a force applied on it, which is going upwards, it's not going to fall down because the gravity is a lesser force than the throw force. So we are going to set rb.gravity scale to be equal to 1. And then in the next tutorial, we are going to do something in here. So we are going to put a to do comment over here. So to do, and we want to decrement number of available knives in the next tutorial. All right, so that's it for the void update. Now we're going to implement another Unity method. Its name is private void on collision enter 2D. So on collision enter 2D, and inside we first want to check if the knife is not active, so not is active, and if it is not, we are going to return from this on collision enter 2D method. And that's because we don't even want to detect collisions and do something with those collisions if the knife is not active, meaning that it already hit some other knife or it already hit the log. Then we are going to set is active to be false. So if this doesn't return, it means that it is active, but once it hits something, we want to set it back. We want not back, but we want to set it to be inactive. Now, if the knife collides with the log, so if collision, which is this parameter of this method, collision.collider.tag, this is the collider with which we have collided. The knife has collided with this collider. And if the tag is equal to log, and we are going to set the tag for the log in just a little bit, but for now let's focus on coding in this script. So if it hit the log, we are going to stop the knife from moving. So we want to set the rigid body's velocity to be a new vector 2, and it's going to have both coordinates set to 0. So this will stop the movement of the knife. Then we will want to set the rigid body to be body type of kinematic. So rb.body type is equal to rigid body type 2D kinematic. I'm going to explain in just a bit, and it's going to be clear once we have the second line in place. And the second line is transform, which is the transform of this knife. And the knife should have a parent of collision, not collider, collision dot collider dot transform. So what does this second line do? And then I am going to explain this line. So the transform in this case is the transform of the knife. And you know what? I'm probably going to put a this over here. So this dot transform is the transform of this particular game object, which is the knife. And we want to set the knife's parent to be equal to the transform of the log, right? This collision collider.transform is the other object with which we have collided, and in this case it is the log game object. And then we are also setting this knife's rigid body's body type to be kinematic so that it can inherit the log's rotation. Because children of game objects automatically inherit rotation of the parent, and we want this knife to inherit the rotation of the log, that's why we are setting its parent to be the log. But if this knife remained to be dynamics body type and not kinematic, it would have problems with inheriting the rotation of the log. So that's why we need to set it to kinematic, because if it's kinematic, it doesn't care about outside physics forces, it ignores them. Then we want to move the collider away from the blade, which is stuck in the log. I'm going to explain in just a bit, but for now, let's focus on the code. We want to get the knife collider, which is a field which we have added in here. So knife collider. And on this knife collider, we want to set a new offset, and this will be equal to new vector 2. And the new vector 2 will remain, the x coordinate will remain. So we want to set it to knife collider.offset.x. So we aren't touching the x coordinate of this vector, but we want to change the y coordinate to be minus 0.4, and it's going to be a float. And then also we want to change the knife collider's size to be also a new vector 2. And we are again not going to mess with the x coordinate, so knife collider.size.x will remain as it is, but the y will be 1.2 float. All right, and then in the next part we are going to spawn another knife over here, so to do spawn another knife. So let's get into Unity Editor, and I'm going to explain briefly what this does. So when we select this knife, you can see the collider as the green outline right here. And when we hit the log, this blade will be stuck inside the log, and we cannot have a collider over here, so that's why we are changing it to be minus 0.4 in y offset, so minus 0.4. And the y size is 1.2. So that's how the knife's collider will look once it's stuck in the log. The reason why we cannot have the knife collider as big as it was before it hit the log, once it hits the log, is that knives could think they have collided when the player shoots them really close to each other because the log is round. And because of the roundness of the log, when we have two knives really close to each other, their blades will be intersecting, and that intersecting blades will be a collision, and we don't want to have that, because in knife hit you can hit those knives really close to each other, they can be almost touching each other, but you are not going to get a collision, and you will not get the game over. So this is the reason we are changing the size and the position of the knife's collider. So let's change it back to how it was before. And let's get back to coding. We have the last two lines to write in this tutorial. So right over here, we are going to put an else if the collision collider.tag is knife. So if we hit another knife, we want to set the velocity of the rigid body. So rb.velocity is equal to a new vector 2, and we want the knife to start rapidly moving downwards. So we are going to set it to rb.velocity.x because we want to remember, we don't want to change the x velocity, we only want to change the y velocity. So we are not touching x, but the y is -2. All right, so this starts the knife to rapidly move downwards. Cool, so this is the last line of code which you are going to write in this tutorial. So now let's get back to Unity Editor. And the last thing that we need to do is to add the tags to the log and also to the knife. So select the log first. We are going to create a new tag. So click on this untagged. We want to add a new tag into this list. The first will be log, save, and the second is knife, save. And on the lock, we want to have the lock tag applied. And on this knife will be obviously the knife tag applied. And we can save the scene. Now the last thing that we need to do is to drag the knife script over to the knife, just like this. Probably over to the hierarchy. Yes, here it is. So, and we also want to change the throw force to be 40 on the Y. So save it as such. And the last thing that we need to do is to test it if it works. So let's launch the game. And we can see that yes, the lock is rotating. And when we click somewhere inside the game screen, the lock will be hit. But we have one last thing which we need to do, and that is to go over to the knife, and we need to, or actually to the log, and we need to set its order in layer to be, for example, 1. And when we save this, we aren't gonna get that the knife is actually in front of the lock. So we need to change the order in layer of the lock so that it's not behind the knife, but in front of the knife. Let's play it again, and hopefully this time it's going to be just fine. Yep. But as you could see, the lock actually has moved upwards, so we need to fix this. The simplest way to do this is to go into this locks, rigid body 2D, go into constraints, and we want to fix position X and Y, and save it. And once the position of the rigid body is freezed, we can play the game and it's not going to move. Alright, cool, and let's test it again. So play and hit, and it's not going to move, and that's how it should behave. Alright, so in this first part you learned how to make a semi-functional knife hit replica. The basic game mechanics are fully implemented, and in the next part you will learn how to make it fully functional by creating a knife count, spawning knives, creating a game over sequence, working with UI, creating game over effects including particles, and much more. So be sure to stay tuned for it, and if you don't want to miss it, hit the bell button and also subscribe to this channel so that you are notified about all of my new videos. Check out the written tutorial from the link in the video description and go through it at your own pace. If this video helped you, give it a like and also share with others so they are also going to know how to create a knife hit replica in Unity. Then, if you have any suggestions or questions or anything else to say, leave it in the comments. Follow me on social media and see you in the next video.